Welcome to my class. Continuing with the topic of characterization of and classification of rocks and minerals. Today we will study the characterization and classification of minerals. Rocks we have already discussed. So first of all, what is a mineral? Mineral is basically a naturally occurring homogeneous inorganic mass. Homogeneous inorganic solid, or you can say mass. So first of all, it is homogeneous, inorganic and solid form. This is composed of atoms. So mineral is composed of atoms, and these atoms are arranged in orderly and regular manner. That means the structure of these minerals, that is in order, that is regular structure. It's not that it is somewhere it is randomly placed atoms. These atoms are arranged in a regular order, and they have definite chemical composition. For example, if we say that H2SO4 sulfuric acid, it is composed of 2 atoms of hydrogen, 1 atom of sulfur, 4 atoms of oxygen. Similarly, the minerals, they have a definite chemical composition. Based on that chemical composition, the minerals, they are named, they are classified. So if we say a particular name of a particular mineral, it will have a definite chemical composition, and at the same time they have characteristic geometric shape also. That's very important. Characteristic geometric shape. And study of these minerals in the soil is called as mineralogy. Not only soil, mineralogy is study of minerals, and study of minerals present in the soil with respect to the fertility of the soil, that is soil mineralogy. And we have around 4,900 species of these minerals which are known to us, and they have in soil, so I should say, with respect to soil fertility, the minerals, they release nutrients. Nutrients are ions which are required for the growth of the plants. So there is, you can say, a direct relation between soil fertility. So relevant from soil fertility point of view. That's why it's very important study of mineralogy, soil mineralogy, because if you know the mineralogy of the soil, only then you can have an estimate about the fertility, inherent fertility of the soil. Then minerals can be described by various physical properties, described by various physical properties. And these physical properties are related to the structure and chemical composition and composition of the mineral. And these properties could be luster, that means the extent of shine of the minerals, then crystal structure, hardness, then color, streak, tenacity, cleavage, etc. So these are all the physical properties, and these physical properties, they distinguish different minerals. So many a times we classify the minerals on the basis of their physical properties like luster, structure, hardness, color, streak, tenacity, and at the same time these properties of the minerals, these are related to these ultimately give a particular shape, particular composition, particular physical property to the soil itself. Then classification of minerals. Now minerals can be classified as, basically we have broadly three groups of minerals. So we won't be going into details of the mineralogy over here. So that will be basically beyond the scope of soil, fundamental soil course. So minerals, their classification. So first group is primary minerals. Primary minerals, they are formed by crystallization of molten magma. Crystallization of molten magma. Like we have primary rocks which are formed by the crystallization, cooling of the magma. And therefore these are also inherited from the igneous rocks, because igneous rocks are also formed from molten magma. And then igneous rocks, we discussed in our last topic that when igneous rocks get metamorphized, they get changed, or weathering takes place over the time, you have the formation of metamorphic rocks. So basically metamorphic rocks which are evolved from igneous rocks, they also have the connection with the molten magma. So the primary minerals, they are inherited from igneous and metamorphic rocks. And of course these are formed at elevated temperatures. So primary minerals, because they are formed from molten magma, so these are formed at elevated temperatures. Because the extent of temperature at which a mineral is formed, that gives different type of shape, color, luster, etc. to the mineral. And chemically unchanged. These minerals remain chemically unchanged. Even if these minerals, they undergo the process of weathering, their chemical composition remains unchanged. And percentage of primary minerals, in soils depends on extent of sand and silt content. Extent of sand and silt content. Higher the amount of sand and silt content in the soil, higher will be the proportion of primary minerals, because oxygen and silicon ions, they together with one or more cations are combined to form silicate minerals, and 90% of the 90% silicate minerals are present in earth crust. So the earth crust is dominated by the primary minerals, or you can say the silicate minerals, formed by the combination of oxygen and silicon to form silica. So some of these silicate minerals are like you have quartz, silicate minerals. In this we have quartz, feldspar, pyroxenes, amphiboles, then hornblende, olivine, mica, muscovite, and biotite. So these are all primary silicate minerals present in dominance in the earth crust, and that earth crust is basically your soil. Then second category of minerals is secondary minerals. Secondary minerals. Secondary minerals, as in case of rocks, these are formed by weathering of primary minerals. So primary minerals, when they weather out, they undergo weathering process, they get converted into secondary minerals, and most common in these are clay minerals. Most common in clay. Like you have primary minerals in the form of sand and silt particles. Similarly, the soil having higher amount of clay, that will be dominant in secondary minerals. So some of silicate clays are number 1 kaolin, number 2 is your smectites, then vermiculite, then mica, and chlorite. So these are some of the silicate clays. Then non-silicates, we have hematite, hematite is basically iron oxide, Fe2O3, ferric oxide, then goethite, Withite is your FeO, iron oxide, N part atoms of nitrogen, crystallized water. This is goethite. Then gibbsite. Gibbsite is aluminium hydroxide. Then you have calcite. It's calcium mineral. It is calcium carbonate. And then we have dolomite. Dolomite is calcium magnesium carbonate containing both calcium magnesium carbonates. Then gypsum. This is your calcium sulfate with 2 molecules of water. And then you have apatite. Apatite is calcium and phosphate mineral. So some of non-silicates and silicate clays. So this is second group, that is secondary minerals. After this, the third group of minerals is accessory minerals. So third category, third class of minerals, they are called accessory minerals. Accessory minerals are basically, these occur in only small quantities. In the soil as well as rocks, but these are not essential. Otherwise, from soil fertility point of view, both primary group of minerals and secondary group of minerals, they were essential, they are important. But here accessory minerals, they are not important, they are not essential rather, and they form a group of heavy minerals. Due to their high specific gravity. And in some of the soils where these accessory minerals are present, its particle density is higher because these are heavy minerals with high specific gravity. So the soil containing these type of minerals, it will be having higher particle density. Otherwise, we have a very narrow range of particle density, that is 2.5 to 2.6 megagram per cubic meter. But when you have presence of these heavy minerals, then particle density increases. So some examples are like you have zircon, SiO4, then you have zeolite. Zeolite is calcium, iron, sodium, potassium, silicates. Then pyrite. Pyrite is iron sulfide, and magnetite is your iron oxide. Then ilmenite, it is again iron, titanium oxide, and then you have barytes, it is barium sulfate, and lastly you have serpentine. Serpentine is magnesium, silica, hydroxide. So with definite chemical composition, high specific gravity, we have these third group of minerals, that is accessory. So this is the broader classification of minerals. When you are at studying at the fundamental level of soil science, so this type of classification is sufficient. But for higher courses, yes, of course, you have to go into much more detail. So I hope the things are clear. Thank you very much.